go by or not be answered fully. So limit as x approaches 2 from either side, the square root of 6 minus x minus 2 over the square root of 3 minus x minus 1. What do we do when we are asked to find a limit? What is our first step then? Again?
Plug it in?
Yes, we have to plug it in. We have no choice. Good. So can anyone give us the numerator and the denominator? Anyone?
The top is 0. 0, 0.
Of course. So now the question is, what do I rationalize? So how do I answer this question for this situation? Do I rationalize the numerator or the denominator? The answer is both. I have no choice. So when I rationalize the numerator, what do I rationalize it by? I have to write the limit again.
The conjugate?
Yes, very good indeed with the conjugate. So the conjugate for the numerator will be the square root of 6 minus x plus 2, the square root of 6 minus x plus 2. And for the denominator is the square root of 3 minus x plus 1, the square root of 3 minus x plus 1. Okay, so let's see what we get. I will have to multiply these two, and I will have to multiply these two. The rest will stay, because the rest is not a problem. This is not a problem. This is the square root of 4 minus plus 2, so 2 plus 2. This is 4. This is not a problem. This is 1 plus 1, which is 2. So these are fine. But I have to get rid of this problem, because this is the 0. Okay? And this is, so this is the 0 as well. Right? So that's the problem here. So limit as x approaches 2. I'm going to write these two in front. So the square root of 3 minus x plus 1 and the square root of 6 minus x plus 2. Now, can anyone give us this product? And then somebody give us this product?
Minus x plus only minus 4.
Yes, 6 minus x minus 4. Perfect. So this is done. Thank you, Sean. And these two?
3 minus x minus 1.
Perfect. So now I'm going to cover it for a second. What is the factor that has to go away if this limit exists? Which is the factor that creates 0 over 0?
Would it be x minus 2?
Of course. That's the problem. This is what I'm after. If this limit, thank you so much, Katie. If this limit exists, an x minus 2 from the top with an x minus 2 from the bottom should go away. Otherwise, the limit doesn't exist. Or it's an infinity or whatever. So let's see. So let's continue. So limit as x approaches 2. I'm going to copy this one more time. Please notice the limit operator does not disappear. Please. So the square root of 3 minus x plus 1, the square root of 6 minus x plus 2. So now, so this is negative x and plus 2, and this is negative x and plus 2. It's the same thing, right? With minus in front. It doesn't matter, but they are the same. Thank you. Goodbye. Now we apply the limit operator, and it drops, it disappears, and now we can write the limit. And what is the limit?
1/2.
Very good, because this is, we already talked about that. 1 divided by 2. So this could have, so this is the 1 plus 1, yes, 1/2, because the numerator is 2 and the denominator is 4. 6 minus 2 is 4, the square root of 4 is 2, 2 plus 2 is 4, so this goes to 4, and the numerator goes to 2. 1 plus 1. Very good. This is it. So the moment I saw that question, thank you so much for your question, I thought to show this. So my answer is, I don't have one. It depends on where the problem is. But here the problem was in the top and the bottom. Now, on a previous problem that we worked on, somehow I always go back and take this out of my bin, recycle bin. So there was that here. See? Here the problem is in the numerator. I have no choice but to rationalize the numerator, because the numerator is the problem, is infinity minus infinity. Who knows what this is? It turns out that we got that infinity minus infinity this time to be 1/6. Who would have known? Right? So here it's very clear. I have no choice. I have to rationalize the numerator. So I cannot give, so as the final answer, and we can put that to rest unless you have questions, I cannot give a recipe. It depends on the problem. Good. Other questions for me? I'd like to share my screen to go to another problem. Any questions, anyone, please? Again, thank you so much for the question. So I want to look at 2.7 with some other problems. Okay, am I still in 2.7? Yes, I am. I want us to talk about rate of changes and measurement units. So I'm looking at a problem. Equation. Well, no. Cost. Yeah. Okay. So the cost of producing X ounces of gold from a new gold mine is C equals F of X in dollars. So once I see this, oops, I didn't mean that. Once I see this, I know that C is measured in dollars and X in ounces. So I'm going to stop for a second. So what problem was it? 51. Okay. So this is 51 in 2.7. Okay, so we have C equals F of X. I know that this is measured in dollars, and I know that this is measured in ounces. At any point in time, I'm pushing my device further. At any point in time, if I am asked, I don't even know, I didn't read the problem, but if I'm asked to find this, the measurement unit has to consist of 2 measurement units. So if I'm asked to find the rate of change of cost with respect to number of ounces, the measurement unit has to be cost over ounce, because it's the y variable divided by the measurement unit of the y variable divided by the measurement unit of the x variable. Rise over run. Rise, measurement unit of y, run, measurement unit for x. So this has to have measurement unit dollars per ounce. Okay, so once we establish that, remember, for the rate of change, always 2 measurement units. One for the y variable and one for the x variable. Okay, back to sharing here. What is the meaning of the derivative f prime of x? And what are its units? We already established. I wanted to establish that regardless of whether they were asking us or not. So what is the meaning of the derivative f prime of x? Can anyone say something? Or c prime of x, the same thing. Can anyone explain what that means?
The slope of the tangent line at x.
At every point, so f prime of x or c prime of x, same thing. It's the slope, that's one way of explaining it. Slope of tangent line at f of x, where f of x is
Differentiable.
Thank you very much. Exactly. Here's another way. Instantaneous rate of change of c with respect to, lazy people write with respect to like this, c with respect to x. If you want cost with respect to ounce. Instantaneous rate of change. Or the slope of the tangent line. Same thing. Good. What does the statement f prime of 800 equals 17 mean? F prime of 800 equals 17. What does this mean? Can anyone say anything?
Would it be $800 for 17 ounces?
Careful. Careful. What did we say x was?
Oh, 800 ounces for $17.
When 800 ounces are produced, the rate of change of cost is, what do I write and what is the measurement unit?
$17 per ounce.
Thank you very much. Perfect. Thank you very much. Any questions? Great job, everyone. I'd like to hear from everyone, though, please. Do you think the values of f prime of x will increase or decrease in the short term? What about the long term? So let's see. What do you think? And how do we think about this? It's not an easy question to deal with, right? How will I know where the cost will go, right? How do I know about the demand? So what do they mean by short term and long term? So short term is something like a year, pretty much, short term. 1 year could be. Long term could be 10, right? So in the short term, what will you say? What will you say in the long term? Long term, normally gold over a long time, it goes in price, it goes up. Short term, it could go down. So this is more, I guess, it will increase or it will decrease.
I have an answer.
Yes.
Okay, so in the short term, the tangent line will be flatter, so it'll have a decreased value.
So
and
in
in the long term, it'll be
not as steep.
yes.
Excellent. Perfect answer. So a flatter slope in the short term and more acute slope in the long term. Perfect example. Perfect answer. Okay. Very good. So let's finalize this with section 2.8. We already talked about the derivative. We graphed the derivative. We already looked at some examples and finding the derivative using